Hello, AP Statistics students, and welcome to the College Board virtual instruction for AP Statistics. My name is Luke Wilcox. I'm an AP Stats teacher at East Kentwood High School in Kentwood, Michigan. I just want to say thank you to the thousands of students that have been joining us live over the past few weeks in preparation for the AP Stats exam. But today, we are going to take a very important departure from our typical lessons to bringing you some insight and wisdom from a guest speaker, and not just any guest speaker. Today we have with us the biggest celebrity of modern statistics, founder of FiveThirtyEight.com and author of New York Times bestseller, The Signal and the Noise, Mr. Nate Silver. Thanks for joining us today, Nate.
Thank you, Luke. I'm really happy to be here. Happy to be talking to everyone today. I know I can't hear you guys. Hopefully you can hear us. But I hope I can provide some guidance and entertainment at a time I know it's tough for a lot of people right now.
Excellent. So I do want to give our students a little bit of background if they may not be familiar with all of your work here, Nate. Nate actually started his career developing prediction models for baseball players using an advanced system that he actually developed called Pacoda, which is still used today. He jumped into the spotlight in 2008 when his political prediction model accurately predicted the outcome in 49 out of 50 states in the presidential election. This is when Nate developed FiveThirtyEight.com, a website which has now grown to cover data analysis related to politics, sports, science and health, economics, and culture. Now, Nate, here comes my own personal opinion.
Okay.
I think what you have done for statistics is what Neil deGrasse Tyson did for astrophysics. You've taken a subject area that has traditionally been like geeky and boring and difficult to understand, and you've transformed it into a subject that's like popular and interesting and accessible to the masses. And I think it's this transformation that has earned you your celebrity status, which you definitely have amongst the AP statistics community. So,
yeah, I appreciate that. I do think, though, there's a lot of it of being in the right place at the right time, because we're now all in a world now where we encounter data all the time, right? And where we are taught to kind of do our own analysis and kind of question people's conclusions and do our own work. And so I think like we're all confronted with this. And one of the messages I want to get out here today, I know obviously if you're in AP statistics, you maybe don't need to hear this as much, but like statistics shouldn't be seen as something which is counterintuitive, right? It shouldn't be seen as something which is only academic or obscure. It's something that like has as much real world applicability as any other course that you're studying, if not more. And so that's partly what I want to get across to people.
Excellent. So maybe we could start. I mean, we've got high school students here with us that are making big decisions about their lives, considering what degrees they might go into, what jobs they're looking for. So why don't you start by just giving us a little bit of your own personal background in terms of your education and your professional journey.
So I went to East Lansing High School. Actually, we both went to the same, both grew up part of our childhoods in East Lansing. So good public school. Went to University of Chicago after that and majored in economics. U of C has a very quantitative focus. So it's a pretty quant heavy economics program, but also U of C encourages you to take a common core of courses. So you're taking humanities courses and literature courses and art courses and whatever else, right? And I do believe that's important too, that the context for where we're applying our analysis is always in the real world, right? And there are moral considerations and ethical considerations, and also just like having context and understanding what you're actually analyzing is always important. From there, I took a consulting job. I was a management consultant for KPMG, which is a big consulting and accounting firm. I didn't love that job. It was okay. So that's kind of where the part of the story we were talking about before, that Luke was talking about before, picks up, where I started on the side working in a projection system for Major League Baseball players called Pacoda. Eventually, I left my consulting job to do that. Also, I don't know if I should be telling high school students this part or not. I was also playing a lot of poker at that time. There was, in the mid-2000s, a poker boom. So if you kind of, you got to be careful here, right? But like at that time, it was relatively easy if you were good at poker to make money. Now it's not. Now it's very tough to do that, and now it just would not be advisable. But there was a little bubble that took advantage of. Um, but having been in the sports sphere for a while, I know some of you might know the book Moneyball, be familiar with the concept of sabermetrics in baseball. I saw how much progress was being made in baseball, where teams were becoming, they would hire their own statisticians and analysts and become much more data driven and much smarter about making decisions. When I looked at the political space, there wasn't as much of that. I should say, campaigns themselves are smart and data driven, right? If you're looking at Bernie Sanders' campaign or Joe Biden's campaign or Elizabeth Warren or, Donald Trump to some degree, they're all like using data to find out where their voters are and kind of what policies might be popular and whatever else. But the media coverage of campaigns tended not to be that way, right? There was a lot of focus on narratives and conventional wisdom. And so I founded FiveThirtyEight kind of as a response to that. Both focused on the specific question of, okay, how can you build a model that takes all this polling data we have and turns that into a probability for which party might win in which states, but also more generally, just to provide more data flavored analysis of politics. So that's kind of long and short of it. It's kind of like, I am someone who believes in following your passion, right? And working hard. And if you kind of find that there's something out there that you think is a need in the market and no one else is making it, then maybe you have to be a little bit creative in terms of building a product for yourselves.
Excellent. Thanks for that quick review of to get you to where you are today. I'm gonna go back to students here. As a math teacher, we're often asked by students, when am I ever going to use this? And at least in this class in AP Statistics, I can very confidently say that you're going to use it all the time, because statistics and data analysis are becoming such an important part of our modern literacy. So why would you say that statistics is so important in everyday life?
I mean, so I'd start out by saying, the reason why we're all gathered here online today instead of in person in our own classrooms is because of coronavirus. And almost every aspect of coronavirus, having knowledge of statistics would be extremely helpful, right? Ranging from diagnosing the number of cases in a particular area, because it's not as straightforward as it might seem. If you all of a sudden do a lot more tests in an area, then you'll get a lot more cases, so you have to adjust for that, right? When you're doing tests, hey, we have a new therapy, hopefully it helps some people and helps them recover sooner or avoid dying. The math behind those tests involves a lot of statistics, because you have to be careful about not taking one quirk result and assuming that now I've all of a sudden cured COVID or something. And so, epidemiologists trying to predict, hey, where will there be an outbreak? Where will the peak be? What will happen if we do or don't do certain measures? The fact that a lot of experts were very worried about this before maybe the average person was, because they understand exponential growth and how, okay, well, you might start out with 5 cases, but if 5 doubles every 3 days, and you do that for a couple of weeks, all of a sudden you can have thousands of cases. So, the most important thing that the world's faced in at least a decade or two, statistics is very important at that. But in more normal times, I mean, obviously, political campaigns need to be smart about who their voters are, how they can persuade them. Baseball teams need to be smart about it, right? If you're running any type of business, people, I think, there's a spectrum between kind of hardcore academic statistics and more casual versions of it. And kind of anywhere you wind up on that spectrum can be valuable too, right? Having good intuition for, okay, when I'm looking at a problem, when does something look a little bit funny, right? That intuition is certainly related to statistics. It might not be formal statistics, but that's important as well. And so to me, it's almost, you could almost flip the question and say, okay, what are fields that don't involve some degree of statistics, right? Or at least kind of quantitative reasoning. And I think there are relatively few where you can avoid areas like that you can get away without having some knowledge of, just interpreting the data in your world, having intuition for how to frame a question, look at a problem, and get a sense for the direction of things.
Yeah, so I think I'm hearing a couple of things from you here. One is that like statistics is often involved in like big decisions that have to be made, even at high levels, in terms of, the COVID pandemic or even if you're a manager of a baseball team and there's decisions there. But the flip side of that is that the general public also has to have some sort of understanding of statistics in order to be able to interpret information that they receive from the media. And one of the things that I guess concerns me a bit is not for our students. Our students are getting some training in statistics in high school, but a lot of the general public has not received any formal training in statistics. So what do you see as some of the most common misconceptions of the general public as it relates to statistics?
So I mentioned one of them already, which is the notion that statistics are counterintuitive, I think, or, oh, kind of math makes my brain hurt. I don't think that's true in general. I mean, there sometimes are cases where there are counterintuitive things when you get into like Bayes' theorem and things like that, right? And part of what behavioral economists try to study is, for example, where are things where our first kind of level thinking, where intuition can lead us astray. But for the most part, we're dealing with the real world and things should be fairly intuitive. And part of what quantitative reasoning can help you to do is think more precisely about things, right? Sometimes it's pretty important to be precise and exact. Sometimes it's not as important and it can be approximate, but having a sense for when you can be more exact and when a range is okay. But the other big thing I think is understanding probability and uncertainty. Where if you tell some people, okay, this thing has a 30% chance of happening, people might interpret that very differently, right? Some people might say, okay, 30%, that sounds pretty high, I should be worried. Some people might say, okay, well, that means 70% chance that it won't happen, so I can kind of ignore the 30%, right? And understanding what probability means, understanding that one of the reasons why we use statistics is to quantify uncertainty, right? To say, okay, well, if you flip a coin 100 times, right, on average, it'll come up heads 50 times. So there's a distribution of like, how often we get 60 heads or 42 heads or whatever else, right? For a coin, it's easy because you actually know the exact properties of the coin. In other fields, you don't really know exactly what the true distribution is. So you have to use inference and it can be more tricky. But understanding and actually saying, hey, here's a range of answers. Hey, here is a probability. Here is a degree of uncertainty. And sometimes even saying, I don't know, right? Those are often really valuable skills, and often people who have more training in statistics are better at doing that, right? They know that it's not about coming up with if you can get exactly right, then an exact answer is great. Most of the time in the real world, we're dealing with issues where we are trying to make difficult decisions in real time. And we have a limited amount of information, and some of that information might be noisy, some of the data is good, some of the data is not so good. We're in a competitive market, so if we make an error, someone else is poised to take advantage of it, right? People might misinterpret things. So in many ways, it's like actually both very difficult, but also very exciting because you are dealing with having to make real decisions and using both your mathematical and statistics training, but also kind of your reasoning and your understanding of the people and the systems that you're studying.
Excellent. It's funny that you say probability is one of the most common misconceptions because as a general rule, our students tend to say that is the content that gives them the most trouble is probability type questions, but certainly something that's valuable to have in real life. Now, next question here is our students, our AP Stats students will be moving on to schools to go after degrees in a variety of different contexts, from psychology to biology to the arts. But there may be, and I know that there are some students who have really enjoyed the class and may be considering a college degree in statistics. And I know one of the big factors there is like, what does the job market look like? So what types of jobs are currently available that require good working knowledge of statistics?
I mean, I think there's still a huge boom in data science jobs. So almost any industry you might want to go into, from working for a tech firm in California to working for a state or city government, right? By the way, all these cities and states are going to be hiring a lot of contact tracers, which is people that are using, kind of inferential techniques to figure out, okay, if I got sick, who else was I in contact with? That can involve an element of data analysis for sure. Even in journalism, which is a field that I'm involved in, at least most immediately, having a background in data is really helpful, whether it's a matter of doing your own coding or just kind of interpreting things that public officials say and wanting to say, okay, when a governor or a senator or a president or a candidate makes a certain claim about something, then how much can you scrutinize that claim? So I think there is a very broad appetite for statistical skills, including in things where, like, even if you're not involved exactly in data science, there are a lot of jobs now where it's adjacent to what you might be doing. And it really is pretty broad-based. This is kind of the classic, like, finance and stuff like that as well. Not for everyone, but it is lucrative potentially. And that's obviously very data-driven field as well. And medicine, I mean, again, it's like you almost have to enumerate the fields where it isn't relevant to have some training more than the ones it is. It seems like there's still a fairly big under supply, right? One thing you'll find is that a lot of college stats programs actually many students come from abroad, which is, number one, a good sign for the American education system, but also number two means that, like, it means that our country people who are born here, maybe that isn't enough to cover the demand that there is in the US and worldwide for all the data-driven talent and jobs that we might need. So it's very much, from a career perspective, putting yourself in a position where you will have more opportunity and more leverage to kind of pick a career path that you find meets your needs.
So I'm definitely hearing that there's a lot of opportunity within statistics specifically in terms of the job market, but even in jobs outside of statistics, a good understanding of statistics can help you within those fields, such as even journalism, medicine, those sorts of things.
Yeah, I think, it's part of being a good citizen too, right? That being a good consumer of information and understanding when to kind of take something at face value, when to be a little bit more skeptical. Again, look, statistics is really kind of at the core of a lot of science, where we're trying to prove claims based on evidence. And the way you prove something is more or less with statistical analysis, right? I mean, you might actually be doing like an experiment with chemicals and chemistry, right? But the way you prove whether there's a significant result or not, whether it's real or not, something that you see in experiment, it ultimately comes down to stats, right? And so it really is kind of the backbone of everything from science to not the only part of point of background, but it's an important part of the toolkit of being a good informed citizen as well.
Okay, I'm going to shift topics a little bit here, and you mentioned a little bit about this in your intro, but back in 2008, you decided to sort of expand outside of the world of sports and thinking about how you can use statistical analysis and predictions, specifically within the realm of politics, which you said was one of the sort of driving forces that helped you to start FiveThirtyEight.com. And then, of course, since then, the reach has expanded even further outside of politics. So what is it that pushes you to continue to sort of grow the different spaces where you can utilize some of the things that you know about statistics and prediction models?
I mean, part of it is, like I said earlier, part of it can be frustration at kind of how I see things are covered elsewhere, right? That's a more negative motivation. A more positive motivation is that it's nice to find that you have an audience of like-minded people. And that, for a long time, I also, by the way, I work partly for ABC News. So FiveThirtyEight is owned by ABC News. If you, my official job title is, at ABC News, right? And so that's a field where for years, network news maybe was afraid to kind of show data. And we're like, oh, if we show people numbers, their kind of eyes will glaze over and they will tune out, right? And that's flipped a lot now, where I have a weekly segment on ABC News where we're talking in numbers. There are kind of numbers flashing on screen, and it actually is a way now to build credibility with an audience, right? Because we are in a world now, for better or worse, and covering politics, I know that, like, look, people are skeptical. Sometimes they're partisan also, right? But they're skeptical at the very least and critical, and they don't necessarily, when someone says something, then their attitude is often, hey, prove it to me, demonstrate it to me, right? And so kind of showing people your work is a really important part of journalism now. And so part of what we're trying to do is just to be more transparent is the buzzword, but saying, okay, if we tell you that such and such candidate has a 60% probability of winning a certain election or winning a certain state, then here's the math that we did to come up with that estimate. And you can show that to people visually, you can show that to people with the numbers, right? I mean, part of what we try to do at FiveThirtyEight is like, there are different types of learners. Some people will learn through data visualizations. Some people will learn through persuasive and accurate writing. Some people just like the numbers themselves, right? They don't need the visualization or need the context. They see the numbers and that resonates with them. Some people, by the way, are also oral, AURAL learners, so they learn by listening to a podcast or something, and that's kind of the way that they kind of absorb the most information. And so kind of having a multi-channel platform, I'm using kind of too many buzzwords now, right? But finding different ways to communicate with people. I think part of what we try to do, again, is to say that, hey, this shouldn't be intimidating, and it can be work sometimes to figure out, okay, here you have a friend who, assume they're a smart friend, but maybe they're not quite as knowledgeable about stats as you might be in AP statistics. How do you talk to them about something you understand, and they're smart enough to understand, but they might not use the same language and jargon, have quite the same training that you have, right? So if you're in journalism, that's a lot of what you're trying to do. You're not trying to dumb things down. You're trying to kind of translate for people who have the right level of aptitude, but maybe not the kind of formal training and understanding kind of what analogies and language and metaphors and examples can help people understand something better.
Yeah, so it sounds like you're trying to take numbers and data and put it in a format that is like digestible by the general public, which might help them to understand a particular story or an issue in better detail than if they didn't have the numbers.
That's right. It's trying to provide, context. Although there are different types of stories, right? Sometimes the numbers are kind of the core of the story, and you have to provide context around that to say, hey, this is actually like, it's not just a numbers problem, it's also like a real world problem, right? That you can have polling in an election, but that polling reflects what real people are feeling, and they're making a really important decision about who will be the next senator or governor or president, right? So that can be the flip side too, where the problem is maybe not a data problem itself, but that data can provide context. Sometimes it can provide kind of more context than others, right? If you look at the amount of gun violence in the US, then it can help to know how that compares to other countries or from state to state, right? That might not, though, be necessarily at the core of the problem, right? And it might not totally explain the kind of fear and loss of life people can have, right? So you have to be careful to not kind of assume that, oh, now we have this tool and we can solve everything with it. Sometimes it is very central, and sometimes it is more peripheral. We at FiveThirtyEight try to focus on things where it is a little bit more central for the most part. But again, that's a pretty expansive list. And we've learned, kind of most of the stories we're doing now, or half of them anyway, are about kind of coronavirus. And so, science and medicine, statistics are very much at the center of a lot of interpretation and arguments people are having.
Excellent. I'm going to ask you a quick question about your book. So the book is called The Signal and the Noise, and I actually got it back in 2012 when it came out. And I can tell you honestly, it changed the way that I think about statistics and even the way that I teach statistics to my students. And the subtitle on the book is Why So Many Predictions Fail, but Some Don't. And so I was hoping that you could provide students with a sort of like a summary of the conditions and the thinking that actually lead to successful predictions.
So it's complicated, kind of as the book's title implies, then often predictions aren't very accurate. But there are a few kind of habits that I think are helpful. One of which is to think probabilistically. I've talked about that a little bit, but understanding that like quantifying and measuring the uncertainty in the problem is often really important, right? That can be easy to look at the polls, say, okay, that candidate is ahead in a certain state, but is there going to be a wide margin of error or a narrow one? It may not be easy to figure out what if you have a whole bunch of elections taking place at once, right? Where you have 50 states and Washington, D.C. all vote on the same day for president, and those outcomes are all correlated from state to state. That becomes a more complex problem potentially. And so understanding probability and uncertainty, understanding that sometimes having more uncertainty is the right answer and the better answer. I mean, I think that's pretty core. I think number two is maybe a little bit more philosophical, but it's kind of knowing what it means to be objective or subjective, because inherently any one person's point of view is subjective. We see the world from a certain viewpoint. And we're trying to basically work with others to say, okay, well, I see things over here and you see things over there. And here's this real world, this objective world that we both have this kind of skewed perspective on. So how can we kind of triangulate and calibrate and figure out what the real world looks like, right? So that's important. Understanding kind of what your own strengths and weaknesses are, what your own biases might be is another way to put that. Understanding that we're never looking at something in a totally neutral context, right? We're not in a pure laboratory setting where, okay, I'm the first scientist looking at this problem and there's no kind of context, but saying, okay, how do we interpret data in a messy real world context where one of the things that's messy is that we might have our own biases, right? If you have a favorite sports team, it's easy to maybe look at that data through a rose-colored glasses where you want your team to do better, right? Or if you have a candidate that you're rooting for. So part of it is understanding the nature of bias. And the third part is really kind of just learning by experience, right? Fields where you've seen a lot of progress being made tend to be fields where there is a lot of repeat trials and errors. So weather forecasting, if you read the book, weather forecasting, if you're in high school, you might not know this. It used to be like when, I'm 42, people like me were in school, or certainly my parents were in school. The weather forecasts were kind of a joke. That whether it was claimed that it was going to rain or snow or whatever else, or be warm or hot, they were not doing a whole lot better than random chance. Or in Michigan it's probably going to be cold in February, right? But you weren't doing a lot better than that. Now weather forecasts are quite accurate for several days in advance, including for things like hurricanes and severe weather. One thing that helps weather forecasters is they actually have a lot of science behind it. So it's not pure stats. It's kind of stats mediated by physics and chemistry and how the atmosphere works. But also you have to forecast the weather every day in every city around the country for 24 hours a day and 12 conditions, weather and temperature and barometric pressure, whatever else. So therefore you get a lot of practice. When you get a lot of practice at something, then you tend to get better at it. And so, look, just like when you are kind of studying something, it helps to have a larger sample size and more data. When you're making your own predictions, it helps to have a larger sample size too, right? I think a lot of people will be in a field where they're predicting kind of rare events, right? And they will either get a lot of credit or a lot of blame for whether any one prediction goes right, when really that's not necessarily, in theory, a great way to judge people. It should be kind of about, okay, if you forecast hundreds of events and I'm right 70% of the time and you're right 60% of the time, that might be a more significant difference. So it's not quite as binary as you might assume, but kind of learning through trial and error. One thing I think is important is that things you might do in the abstract, if you're building a statistical model, that may or may not prove to be as reliable and robust as you thought when it's applied under real world conditions, where there are things that you didn't expect to happen begin to happen, where there is data that is missing, there is data that is wrong, there are unprecedented events that happen, right? All those things can happen. And so how do you build forecasts and models and analyses that are able to withstand kind of stormy weather, so to speak, when things don't go as perfectly as you might hope them to?
Yeah, so actually related to that, to put that into our current context of this COVID pandemic, there's a lot of people trying to make predictions about things right now. How many people are going to be infected? How long is this thing going to be around? What are some of the current conditions that stand in the way of us making good predictions as it relates to the COVID pandemic?
So there are two big problems that I would see and that would make life very difficult if you're a kind of COVID forecaster. Um, Number one is that all of the data to some degree or another is flawed. But let me explain that in more detail, right? So the US is probably only catching, epidemiologists estimate maybe about 10% of the actual infections that we have. And the reason is that, first of all, in many states, this is changing in some states, but not others. In many states, it has been very hard to get a test. So I can get symptoms. I will call my local health agency. They'll say, you know what? There are people with more severe symptoms than you, and they need tests worse than you. So you just stay home and self-isolate for 14 days. And if things get really bad, then call us again, right? So if you're missing a lot of cases, and by the way, some people don't even have symptoms at all. How many is debated, but that's also an issue. So therefore, if you hear that, oh, New York has 3,000 new cases today, that might actually mean that 30,000 people in New York actually acquired a COVID infection today, but we're catching 10% of them. You can say, well, what about deaths? We tend to catch when people die, but we don't always catch it in real time because a lot of people now are dying in nursing homes or in their own homes. When states go back and say, okay, here's how many COVID deaths we think we had, but then we also know that we had, let's say our state had 100 COVID deaths in this period, right? Then we go back and say, but also we notice we have 200 more deaths than normal this month, right? In this county, say. So what happened there? Were those people who died from COVID? Were those people who died because they couldn't go to the hospital when they were having another medical condition, like a heart attack, because they presumed the hospital was full? You know, I don't know, but those are big mysteries that we have to solve. So one thing is like all the data is to some degree or another imperfect. Some is more imperfect than others, and you have to kind of decide how to like make a case based on imperfect information. The other one that maybe is even more challenging is that predictions of COVID are conditional on people's behavior, right? If you have a lockdown and social distancing and everyone abides by that, then cases may gradually decrease. If those conditions are lifted or people just say, you know what, screw it, I'm gonna go do what I want anyway, then you can have potentially an increase. And because it's exponential, going up a little bit over a period of weeks versus going down over a period of weeks can make a really big difference as far as outcomes might go. And so therefore, you know, it's kind of a thankless task because in theory, if you say, okay, well, I predict that X number of thousands of people will die unless we do social distancing. And then because of that, we do distancing. Then people will say, oh, those experts were wrong. See, all these people didn't die. It hasn't been quite so bad. Then it might seem like you were wrong, but actually your prediction was conditional on certain types of behavior occurring. And so therefore, an unconditional prediction versus conditional one is an important qualification. You know, conversely, if I predict the Golden State Warriors to win a basketball game, right, I don't really have any effect on whether they win that game or not, right? At least not in any obvious way that I can tell, right? But if I'm a CDC or something, right, or a prominent epidemiologist, and I issue a prediction saying people will die unless we take these precautions, and people take those precautions, then I can actually kind of negate my own prediction, which is a funny thing. And so therefore, I have a lot of sympathy for people who are trying to make predictions about COVID. And, you know, and you shouldn't expect too much precision. I think it's going to be off by a factor of 2 if you're dealing with exponential things, and that might not be that high, right? With exponential things, you're worried about what if I'm off by a factor of 10? Those can be by an order of magnitude. Those can be bigger concerns when, you know, you get one little thing wrong and things shoot up exponentially, and it can be much, much worse after a few weeks or a couple of months.
Excellent. So I'm going to actually shift to sort of an AP statistics topic, one that's actually really important to me. The idea of the p-value, right? I even know there's a certain teacher that might be on this interview that calls it the holy grail of AP statistics. Yeah. And I know the p-values come under a lot of scrutiny lately. in terms of using it or overusing it as a measuring tool. So I'd just like to get your take in general. Like, what is your take on the p-value?
The take is that it is a very important tool, and it's the holy grail, provided that certain assumptions are true that sometimes aren't true in the real world. The big challenge, and I'm not going to try and be super technical here, right? But like the big challenge is that like p-values implicitly assume that you are doing just one experiment, right? That you're assigned to cover a certain problem. You say, okay, I will design my model this way and see if it works. If I get a positive result, then I will publish the paper. And if not, then I will move on to the next topic, right? That's not how it works in practice, right? In every model that I've designed, then I am trying to use the data in a lot of different ways and say, okay, what combination of variables is interesting to look at here, right? And how do they behave together and kind of, so you might look at like 100 different ways to build a model. If a p-value says, okay, well, 95% confidence or 99% confidence, this didn't occur by chance alone, right? But if I kind of run 200 experiments, you're going to have actually lots of cases where I get lucky, so to speak, and some noise actually looks like it's significant data, right? So you can see a real world example of this when it comes to clinical trials for vaccines or for drugs to combat coronavirus. Some of those will work. People are pretty hopeful. It's an interview with Bill Gates, right? And Bill Gates is optimistic that within a year to 18 months, we'll have some vaccine candidates. And before that, we'll probably have some drugs that help some people out to some degree. But if you're running thousands of clinical trials in different parts of the world, then dozens of those will come up with a significant result initially, whether or not there's anything there, right? And so therefore, if you look at the actual rate of clinical trials and how much things progress in different stages, you see a lot of drop off at each stage. Something that looks promising will turn out upon further scrutiny to have been a fluke. And again, in the end, it's not that bad from a kind of perspective of the economy as a whole or the world as a whole, because some of those will very probably wind up working. But it does mean that you have to be apply a little bit more scrutiny to any one data point when you have a lot of options in terms of how you kind of approach and look at the data. So I don't know. I mean, my view tends to be that like I want to look at a problem from multiple perspectives. I want to have a sense for which things, if I tinker with them, if I change one variable, does that cause the whole system to produce a very different result? Or is it more robust, right? Meaning I can change an assumption within a certain range and still kind of give me the same answer, right? I think in general, you want to aim for systems that fit the second criteria, that, you can kind of toss an idea around a little bit, kick the tires a little bit in different ways, have some unusual data come in and the system handles it relatively well. I keep using this term robust, which is, I don't know if it's a common term you guys are using or not, but that's pretty important to me, is to look at a problem from different angles and to say, okay, look, let's put it like this, like, where does like the kind of experience or the art of statistics come in, and all the experience you might gain by doing it for a number of years? It kind of comes in that phase, right? It's saying, okay, I know the result here is statistically significant, but I'm worried that it's a result of me having set up my experiment in a certain way, and it sometimes can be called p-hacking, right? You keep noodling around until you get a result that has the right p-value, but it might not actually be the best model in the real world. So, but this is really important and really difficult. And I think it's totally fine to learn kind of the classic techniques as a starting point, kind of in statistics 101, but then the kind of 201 part of it is okay, in the real world, things are messy. One of the things that are messy is that you're not just getting one bite of the apple, right? That you're running a lot of experiments and all your colleagues are also running their own experiments, and that creates all types of interesting challenges.
Yeah, I really like what you're saying about like it being sort of like a some of the building, it's like a building block, a thing that you need to start with that can indicate that something might be significant there. But then when you sort of mature in your statistical reasoning and thinking, there's other things that you might consider in addition to the p-value when trying to like make a decision about something.
That's right. Yeah, and this is kind of common in kind of every field where you become sufficiently advanced, right? There's kind of a curve where you're like, okay, I don't know anything about this, and now I know a lot about this, and you kind of realize, oh, actually, I don't know anything still, right? Because now I know enough to know what I don't know, and I think you, at some stage in your maturation, will start to understand that, and it might be because of what I talked about earlier with trial and error. I didn't talk as much about the error part of that, right? But at some point, you might build a model, a predictive model, and it'll say, okay, I can predict with 95% accuracy who will win a NBA game, right? And then you actually apply that, and it turns out you're only getting half of them right, right? Then you'll go back and say, okay, I learned the hard way that like something about the way I built my model didn't kind of lead to the billing that I claimed it would have, and so you can learn that through. I mean, frankly, I think you have to learn it through experience, right? I think it's sometimes a little bit hard to abstractify that concept too much, right? Until you actually build a model or become invested in a model, where you see that, okay, it's actually not a matter of probability, because things, in a probabilistic model, the rare outcome will happen sometimes where it's just way off, right? Things that are supposed to be very rare begin happening all the time. Something way outside of your margin of error happens routinely. And you kind of have to learn the hard way, I think, for some of this stuff.
So you've like shared with us a lot of different contexts for projects that you've been involved with, whether it's baseball or politics. Do you have a particular project or a particular like prediction model that is like a favorite of yours that you've worked on over your career?
So we do have an NBA player evaluation system called Raptor, that I'm particularly fond of. Because Raptor is trying to use a lot of the new data that the NBA makes available on defense, on player tracking that has not been used before. And one thing that's kind of nice about it is that, like, for a long time, people would have intuitions about, okay, well, this player is better than the stats actually assume that he was, right? That they're unmeasured quantities that that we weren't capturing, right? And now that you have more data, you actually can capture some of those things. Guys who were reputed to be very good defensive players, like Draymond Green or whatever, you actually see that in the data, and it's kind of satisfying in some ways to have something that actually does match the conventional wisdom, right? I mean, sometimes it is fun either way, right? It is fun to say, okay, people believe that the stats were missing something. It's nice to be able to say, you know what, actually, this is just kind of folk wisdom, and actually we can be really rigorous, and it turns out that this is just a myth, right? But sometimes the reverse happens too, where you find out actually people are smart and they had intuitions about things, and our data wasn't good enough before, and now our data is good enough. And so you want to be surprised a certain amount of the time, right? You want to find results that are counterintuitive sometimes, or else kind of otherwise maybe you just are p hacking, or you kind of know the result in advance, and therefore you're not really kind of doing the science of kind of discovery. On the other hand, sometimes it turns out that people where there are incentives to get things right can wind up intuiting things pretty well, even if you don't have the right data yet. So it's been fun with Raptor to see kind of, okay, actually, as we get better data, it can actually confirm things that like smart basketball fans and coaches and players knew all along.
So you a big fan of Draymond Green?
I am, yeah. I'm a Michigan State guy.
I know you are. Yep.
Yeah, no, I mean, and he's a guy who like had a lot of so-called hidden value, right? But when you start to look at his defensive value, it really is kind of off the charts as far as, I mean, kind of literally, right? He's a big outlier as far as what he does and things that were not kind of measured very well before.
Excellent. Well, we're approaching the end of our time here, Nate. I want to remind you that the students that are watching today are currently preparing for an AP statistics exam that they will be taking in a couple of weeks. What advice do you have, or what inspiration might you have for those students right now?
Just that this is really valuable, and that I know that, like, look, I understand that, like, I'm just going to be honest here. Like, I thought, okay, well, we aren't going into the office. I'm not going to the office, right? We're all going to have kind of more time. And of course, actually, it's very challenging sometimes to to motivate yourself, right? Where there's a lot of stress about the conditions you're living under. You don't get the kind of abilities to relax with your friends that you might otherwise. I know it's kind of challenging, right? But I would say, look, we are going to solve as a country this coronavirus problem before too long. I'm not going to promise it's going to be overnight, right? But you're still kind of entering into a very big and bright world. You will still have a lot of opportunities, unlimited opportunities, right? And I think making sure that taking a little bit of extra time to study right now, you are going to get a summer break too anyway. It might not be quite the usual summer, but it will be a break. I just think it's kind of really worth it to invest that time and keep in mind that that you do have a whole kind of life and career to look forward to, even though things I know are like kind of very challenging and stressful right now.
Excellent. Well, Nate, I just want to thank you again for taking the time out of your day to join us. I hope that your stories that you've shared about the importance of statistics will inspire some of our students maybe to pursue that as a future career. I know at a minimum, you've provided good reason for these students to work hard for the next 3 weeks in preparation for the AP exam. So Nate, thanks again for joining us.
Cool, I appreciate it, Luke. Thank you.
Students, as a final reminder here, I hope that you will be joining us again tomorrow. Tomorrow will be FRQ Friday with Mr. Murphy. Same place, same time, 2 o'clock Eastern Standard Time. So we hope to see you then.